anaerobic. You take an N and turn aerobic, and that means not aerobic. And when trees or plankton or anything that's biologically produced settles into these either swamps or sediment deposits inside of lakes or oceans, the carbon doesn't get broken down and released as carbon dioxide. It gets trapped. Anaerobic decomposition is much less efficient. You get a lot less energy out of it, and it doesn't release anywhere near the amount of carbon that you get in aerobic decomposition, and therefore the carbon stays in the ground. So all these were the conditions in the Carboniferous that produced these big coal deposits and these petroleum deposits. Basically, here's an outline of how it happens. So here we are in the Carboniferous. You've got a swamp. You've got trees around the swamp. We're talking hundreds of millions of years. So it didn't happen overnight. So imagine millions and millions of years of plants growing and decomposing and getting compressed. As time goes on, there's anaerobic decomposition, and that layer of plants becomes condensed into a substance that's called kerogen. Kerogen is a type of hydrocarbon. It's basically a carbon-rich substance that eventually, under heat and pressure, forms into coal. So our coal seam over here used to be the edge of a swamp. So that's the coal side of things. The petroleum side of things, instead of the swamp at the edge of trees at the edge of a swamp, we've got phytoplankton. These are microscopic plants and animals that are in the water column. They settle to the bottom. They also get anaerobic decomposition, so the carbon is trapped in there, also forming kerogen, and eventually that will form into a crude oil deposit. All right, so similar method by which those two fossil fuels are produced. By the way, this is called biogenic fossil fuel. Bio, what is Genesis is what? Creation. So it's living creation of fossil fuels. Fairly well accepted hypothesis for how this happens, what I've shown you right here. This isn't a fact, okay? We weren't here back then. Remember, remember the distinction between facts and hypotheses, both based in physical reality. One is directly measurable, the other isn't. Okay. There is another hypothesis. I was at a meeting of energy and petroleum bigwigs in Raleigh. This must have been 6-7 years ago. And the audience was allowed to write. It was like an energy forum, big statewide energy forum. And the audience were allowed to write questions on little slips of paper and pass them in. And I wrote a question, something basically having to do with whether it's possible that fossil fuels can arise in ways other than this. And when they actually read my question, and the audience laughed. But the expert that was up there says, well, we really don't know. So this is kind of what we're saying. There was a fellow by the name of Thomas Gold. Very smart guy. He was an astrophysicist at Cornell University. He came up with, well, he didn't come up with, he was the most recent person who really brought it to an English-speaking audience of what's called abiogenic. Formation petroleum. Bless you. This doesn't have to do with coal. It has to do with petroleum. This sort of started off in Russia in the 1800s. And they actually believed that the Earth itself makes hydrocarbons geologically without there being any pre-existing life forms. And that basically the petroleum is percolating up, and then you have these bacteria that live in rock under extremely hot conditions. Called extremophiles. These are bacteria. What does philos mean? If you, anybody know, they're Greek. It means to love. Okay. So extremophile are bacteria that love extreme conditions. As opposed to a phobia is a fear, philos means to love. And these bacteria basically digest fossil fuels, and they live down deep in the rocks, way down deep. And some people think life actually originated in deep sea thermal vents and in rocks, and only later came to the surface. He uses as support for this, if you look at many of the the gas giants, for example, Saturn, Jupiter, most of those gases are hydrocarbons. Methane, there's others, sulfuric acid, and carbon dioxide, and whatnot, but, and in fact, Saturn's moon Titan apparently has lakes of methane. It's really, really cold there, so the methane is liquefied. But these are hydrocarbons and ethane, and there's clearly no life on those planets. And yet they're producing hydrocarbons, and they're loaded with hydrocarbons. So if the only place to get hydrocarbons is from living things, how do those moons and planets get them? So this isn't really supported much, but you know, we've talked about paradigm shifts, and we've talked about that many times. Just because the scientific community doesn't support it doesn't mean it's not true. So keep your eye on that one. They'd have to rewrite all the environmental science textbooks because then, coal is pretty well determined. Coal is produced this way, but petroleum, maybe not. Okay, coal. So we've already talked about this, how it's produced. So I've covered that. Different kinds of coal. This is the process by which coal is formed. So here's an ancient forest. The first stage of coal formation is called peat. How many of you ever gone and bought peat moss? Peat moss? Okay, it's kind of like a fluffy. It's a sphagnum moss, and you can go to places in Ireland or Scotland where the peat piles up really, really thick, and they cut it out of the ground in gigantic chunks, and they use it to burn it. Okay, very high carbon content, a lot of oxygen, a lot of water. Okay, but through time, as you exert more and more pressure on this peat, you squeeze out the water, you condense the carbon content goes up, and the energy content goes up. So you don't have to distinguish between these two, but you do need to know that probably the most low-grade coal is called lignite. That's young coal. Lignite. And then as it continues to get compressed, the next category is called bituminous. And the real good site, the good stuff, good site. Just think of A is anthracitic coal, anthracite. All right, so this has the highest carbon content, has the highest energy content, the lowest water content. Okay, so this is really high quality coal. All right, and so the forces that are acting here is it gets hotter and the pressure gets greater. Pretty well determined. Here's where you find these things. So we already mentioned that. So kind of lignite is, you know, not the good stuff. And anthracite, we've got some here in the eastern part, a lot in Wyoming. We've got some there in the breadbasket. Kind of spotty here, but look at the other big deposits. Australia, Russia, China. Not a whole lot in this parts of Africa or South America. So not so much in tropical areas. Okay, talked about that. Crude oil. So the thing about crude oil is that it's a mixture of many different sized carbon compounds. All the way from methane to much larger carbon compounds. And the process of refining separates out those different sized hydrocarbons. Okay, you don't have to worry about that. We've already talked about oil sands and oil shale. Methane hydrate, I don't think we don't need to talk about that too much. It's basically a form of methane that's frozen, mostly in very cold waters in the Arctic. As seas warm, a lot of that methane is released. Methane is even a stronger greenhouse gas than carbon dioxide. So if we don't use it, if we don't burn it, that methane actually has the potential to be pretty damaging to the atmosphere. Okay, I'm going to stop right there, and we will finish this on Monday. Let's see. You guys, you've read this chapter, right? In 19? Yeah. So I'm going to quiz you on some new stuff that we haven't covered in class. So read chapter 20 over the weekend, and Tuesday we'll do a just very brief quiz on chapter 20. So we'll move on. Okay?
Read chapter 20 on Tuesday, be quiz on.
And then we'll finish this up, and Tuesday we'll get into chapter 20 information. Quiz on chapter 20.